Hey everyone, Mary from Team Lavender here. For those who don't know, our team consists of myself, Lauren, Sanaya, Christian, and Pinky, and we are in Dr. Wantland's Math 1102 class in the spring 2025 semester at UNC Charlotte. Today we are going to present to you a mini mathematics demonstration of how a simple tree diagram works and how it can help us to solve a basic math problem. As we learned in chapter 12 of our textbook, Math Excursions, a tree diagram is another way to organize outcomes of a multi-stage experiment. This method provides a visual representation of how many different outcomes can be created when more than one choice is present. For a simple example of this, imagine that you are standing at a snack vendor that offers two different snack options, a bag of chips or a granola bar. They also offer three different drink options: water, juice, or soda. Not only do you need to figure out what snacks you want to purchase, but because you are a Math 1102 student, you want to apply the new mathematical skills you have been learning in class. To do that, we can, one, figure out how many total snack drink combinations are possible, and two, calculate the probability of picking a granola bar and juice. Let's see how we can visualize this math problem using a tree diagram. We'll start building our tree diagram by first placing a dot to the far left that represents our starting point as you stand there thinking about the first choice, the snack. There are two possible options here, so we draw two branches, one for a bag of chips and one for a granola bar. This first level of the diagram shows the initial decision in our process and creates the first branches of our tree. Next, we'll look at what happens when we have to choose a drink to go with our preferred snack. After you choose from one of the two snack options, then you will need to make another choice, what you want to drink with that snack. This vendor provides us with three different drink choices: water, juice, or soda. You will again be choosing only one. Because we are now at the second level of our decision-making process, we are now going to be creating new branches that grow out from our first level choices. To do this, we will be drawing three new branches from both the chips option and the granola bar option. At this level, our tree diagram has 6 final branches, each one showing a different snack and drink combination.
Let's list all the combinations we see in the tree diagram: chips and water, chips and juice, chips and soda, granola bar and water, granola bar and juice, and granola bar and soda. There are 6 total possible outcomes. And there's another cool way we can do this, which is using the fundamental principle of counting for our math excursions textbook Hoffman, and multiply the total number of options in our first decisions by the total number of options in our second decisions, which is 2 first decisions choices multiplied by 3 second decision choices. 6 total possible outcomes is our answer.
The last thing we would like to do is figure out the probability of picking a granola bar and juice out of all the possible outcomes. Looking at the list, that's just one favorable outcome. Since there are 6 total equally likely outcomes, the probability is 1 out of 6. This can also be written as the fraction 1 over 6. For further study into calculating more complicated probabilities with tree diagrams, watch this YouTube video by either clicking the link below or following the QR code. As we have seen, tree diagrams are a simple way to visualize combinations and probabilities that otherwise might seem confusing. They help us to see each step of a multi-part set of choices and give us a clear breakdown of how those choices can affect possible outcomes. This concludes Team Lavender's mini mathematics video on understanding tree diagrams. Thank you for watching.